In this video, I'm going to show you how to solve a rational equation. And why is this equation rational? Because we have a variable in the denominator. So to solve a rational equation, we want to write an equation in certain form. So first of all, we want to collect all the terms and write it maybe as a single fraction. And then we can use a zero-quotient property. Or we can write it as a single rational expression on one side with something else on the other side, and then we can use the property of proportion. So in this case, I'm just going to add these two expressions and write it as a single fraction. So to do that, we have to consider the common denominator. Since there is nothing here, it's going to be x, so I have to multiply everything by x. Now we can add these two rational expressions together. And here we use the zero-quotient property. Zero-quotient property suggests that if you have two expressions divided by one another and all that is equal to 0, that this could only mean that the numerator is equal to 0, while at the same time denominator is not equal to 0. So this rational equation now becomes this equation, which is a polynomial equation. The only way to solve polynomial equations is to factor it. So if we didn't see any patterns here, we would distribute everything and then try to factor it. But here we have something in common between these two terms. It is x minus 2, so we can factor out x minus 2. So what's left from the first term is x minus 2, and x squared is left from the second term. So all that is equal to 0. So combining like terms, or distributing, or getting rid of the parentheses, and we get this. So here we have a quadratic expression, which we can further factor into this. So now we use the zero product property. Zero product property says if we have a product of two expressions equal to 0, that means one of them is equal to 0, or the other one is equal to 0, or both. So using that property, we conclude that either x minus 2 is equal to 0, or x plus 2 is equal to 0, or x minus 1 is equal to 0. So that means x equals 2, or x equals negative 2, or x equals to 1. So the solution set of this equation is 2, negative 2, 1. And here we have to remember to check for extraneous solutions. So let's look at the original equation, and the only value that x cannot be is 0, because that was in the denominator. So none of these proposed solutions is 0. So we don't have any extraneous solutions. So the solution set is 2, negative 2, 1.